Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our day number 72, lesson number 72. We are in the process of learning how to multiply algebraic expressions. How to multiply algebraic expressions right here. We are on day number 72. What we did today, what we did yesterday, and what we're going to do today on day number 72, and what we're going to do for the remaining 3 days, 70, 73, 74, and 75, is that we're learning what happens when we have two simple linear algebraic expressions. When we multiply them, what happens, what do we get at the end, and how do we actually go about multiplying them. For example, for today we are asked to multiply together p minus 4 and p plus 2. Let's do it then. P minus 4 and p plus 2. So first we have to multiply this guy here. P times p is p squared. Now this p has a positive sign in front of it, this p has a positive sign in front of it. Positive plus positive, positive times positive is just positive. Then we go to this guy here. P times positive 2 is going to give us positive 2p. And then we have to take care of the negative 4 part. This is where the parts get tricky. Pay attention here. This is the negative 4. Negative 4 times the positive p is going to give us a negative 4p. And then negative 4 times positive 2 is going to give us negative 8. Now we have to combine the like terms, which is what we learned in the first, which is what we learned in the day 21 through 50, how to add and subtract like terms, how to add and subtract algebraic expressions. So we have to combine this 2p, positive 2p, and a negative 4p. A positive 2p and a negative 4p is going to give us a negative 2. So we have p squared minus a 2p minus 8. There you go. That's the answer. That's what we get when you multiply this expression with that expression. This is a linear expression. What does it mean, linear expression? Linear means it is raised to the first power. I'm going to give you a simple linear equation. Watch here. If I tell you x plus 1 equals 4. Well, that's a linear equation. X plus 1 equals 4. Because it's raised to the first power. Had it been raised to the second power, it is no longer a linear equation. It is no longer a linear equation. X here has two values. We won't go there right now because we're not ready for it. When the time comes, we'll learn it. But because x is raised to second power, there are two values of x which will satisfy this equation. What does it mean to satisfy an equation? It means the value of the variable that makes the equation hold true. For example, let's look at a simpler case here. X plus 1 equals 4. X plus 1 equals 4. And if somebody comes up to you and asks you what value of x will satisfy this equation, well, that's a very mathematical way, very geeky way, very nerdy way of simply asking you what would x has to be, what values of x will satisfy this equation. In English language, what they're asking you is, what do I need to multiply 1 with in order to make it 4? Well, 1 has to be not multiplied, rather added. What do I have to add 1 to make it 4? Well, we have to add 1 to 3. 3 plus 1 gives us 4. 3 is the value of x, which will make this equation come true. A mathematician will say 3 is the value of x, which will make this equation hold or satisfy. The value of x that satisfies this equation is known as the root of the equation. The root of the equation. The root of this equation is 3. The root of this equation is 3 because 3 plus 1 equals 4. It only has one root because it's raised to first power. When the equations are raised to second power, they have two roots. We'll come to that in a second, okay? Depending on how much time I have, we'll get to that. I'm jumping ahead of myself here. In this expression, for example, if we were to set it equal to 0, if we were to set this expression right here equal to 0, which is what we just did here, if we were to set this expression equal to 0, then what we get here is what is known as a quadratic equation in its standard form. This is written in its standard form. P squared has a coefficient of 1, P has a coefficient of -2, and -8 is a constant. Quadratic equation in its standard form looks something like this. A P squared plus B P plus C equals 0. P is your variable. Traditionally they express it in terms of x, but here since we have P, I start with C. So here, so I stayed with P. P squared, x squared doesn't matter. So here our A equals 1 right here. A equals 1. Our B equals -2. And our C equals -8. And this is what is known as a quadratic equation in standard form. This is written in standard form. Where was I going with this thing? I forget now. I think I'm just going on and on for no reason. Now the question is, what values of x, or rather p in this case, will satisfy this quadratic equation? Let's talk about it for a second. I'm going to erase all of this thing and I'm going to briefly talk about it, like 2 or 3 minutes, as to what values will satisfy it. Watch here. If somebody were to simply come up to us, and give us this equation, if somebody were to come up to you and simply give you this equation, p squared minus 2p minus 8 equals 0, and that's it, and they simply ask you, what are the roots of this equation? Listen carefully. What are, plural. Why are? Because it has 2 roots. Root, as you already understand, is just a mathematical way of saying, it's just how mathematicians speak. Root of an equation means the value of the variable that makes that equation come true. Let me give you one more time a simple example. X plus 3 equals 10. The root of this equation is 7, because x would have to be 7 in order for this equation to hold. To hold means to come true. If x were anything other than 7, it's a hypothetical statement, if x were something other than 7, this equation would not hold. There is only one value of x where this will be true, and it is called the root. Here, because this equation is written to second power, because this equation involves a term with a second power, it has 2 roots. So if somebody were to come up to us and ask us what are the roots of this equation, we'll have to use what is known as a quadratic formula, or we'll have to go through a procedure, what is known as factorization. There are 2 ways we can find out the roots. Factorization or quadratic formula, and we will learn all of that much later in the course. Obviously, we cannot go to the deep end of the swimming pool without having first learned how to swim, and how to swim involves learning how to deal with simple linear equation raised to the first power. We have quite a ways to go here. We haven't even arrived to that yet. The next part we're going to do in the next 25 days is learn how to divide algebraic expressions. Then we're going to get to linear equations, and then we'll learn how to deal with word problems involving linear equations, and then and only then we can go on to something higher, equations involving second power. But since I started this thing, let me finish it in a second. Just give me 1 second. I want to look at the back of the camera. I'll be right back. I'm still here. I want to see how much time I have taken. I have already taken 10 minutes. So I'm going to wrap it up. Look, if somebody were to come up to you and not give you any of this stuff, hide everything here and simply give you this part, and ask you what values of p will make this expression equal to will hold this equation true, we'll have to go through these procedures, which involve some work. But we don't have to go through that. Why? Because we know the parents of this equation. We know the parents. Yes, I said parents. Exactly. We know the parents of this equation. We know which two expressions have to be multiplied together in order to arrive at this equation. And the two expressions that we multiplied together. Okay, I need the room, so I need to erase all of this thing. So two expressions that we multiplied together to get to here were these two expressions, p minus 4 and p plus 2. And if we multiply together, we get this thing. Now, if this is equal to 0, then this must be equal to 0. The question is, when do these two, let me rewrite it, p minus 4, I have to remember, p minus 4 and p plus 2. P minus 4 and p plus 2. When would the product of these two expressions equal to 0? It's very simple. Because we know the parents of this quadratic equation, which we ordinarily do not. We are simply given an equation, we are asked to find what values of p satisfy this equation. We either have to learn how to factorize, or we have to know the quadratic formula, which we're going to learn both when the time comes. But here, because we know the parents, we know that the only way this quantity can equal to 0, p minus 4 will equal to 0 only when p equals 4, positive 4. P equals positive 4, p equals positive 4 will satisfy this equation. I'm going to show it to you. P equals positive 4 is one root of this equation. Look, if p were positive 4 squared minus 2 times positive 4 minus 8. What does it give you? 4 squared is 16, minus 2 times 4 is 8, minus 8. Hey, what do you know? 16 minus 8 does equal 0. Voila. There you go. So positive 4 is one root. What's the other root? Well, the second root is if this quantity equals to 0. Because if this quantity equals to 0, it doesn't matter what the first quantity is. 0 times anything is 0. Similarly, the argument here was if this quantity, p minus 4 is equal to 0, then it doesn't matter what this quantity is. 0 times anything is 0. When would this quantity be equal to 0? P minus 4. When would some number minus 4 equal 0? When that number is 4. 4 minus 4 equals 0. Now here the question is, when would some number plus a 2 equal 0? The answer is when that number happens to be negative 2. And this is how we show it. If p plus 2 equals 0, or p plus 2 equals 0 is only true when p is equal to negative 2. So either this has to be true or this has to be true. And I'm going to show you here now in a different color how negative 2 works. So negative 2 is the second root. This was the first root we found, this was the second root. See right here, positive 4. Now we're going to do negative 2. So I need to erase this part here. P squared, we're going negative 2. Negative 2 squared minus 2p minus 8. Now this better come out to be 0. If it does not, we are in trouble. Of course it will, because we created it. It was not given to us. We created it. We know the parents of this equation. Parents of this equation are these two expressions, p minus 4 and p plus 2. There we go. Negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. Positive 4 and a positive 4 and a negative 8, voila, equals 0. So the roots of these equations are these two, positive 4 and negative 2. But as you can see, there are two values. What I'm trying to make you understand is that there are two values of p which satisfy this equation. Why are there two values of p? Because p is raised to second power. It's a quadratic equation. Had it been a linear equation, linear equations have only one root. There is only one value in the world which will satisfy this equation. P plus 3 equals 37. In this equation, p bloody well be 34 and nothing else. No other value of p will satisfy this equation. P has to be 34 and nothing else. In this equation, p has two possible values. It can be positive 4 or negative 2. Do you understand? Let's wrap it up. This is going on for too long now. Because we are not here to learn today. Today we are not here to learn quadratic equations. Right now we are simply learning how to multiply algebraic expressions. And we have done that. I will see you tomorrow on day number 73. We'll do 3 more examples of this thing, and then we're going to move on to the next topic, which is how to divide algebraic expressions. Okay? I'll see you tomorrow. Okay? Bye.